Welcome to Pharmaceutical and Medicinal Chemistry, Module 4 Central Nervous System Drugs, Chapter 4.5 Synthesis and Therapeutic Action of Diazepam. Learning Outcomes. At the end of this chapter, you will realize the therapeutic importance of diazepam drug. You will be able to understand the stepwise mechanistic pathway for its synthesis. You will be able to comprehend the pharmacokinetics and pharmacodynamics of diazepam and also enlist its indications, contraindications, and adverse effects. The contents of this chapter are Introduction, Synthesis, Properties, Routes of Administration, Uses, Preparation and Doses, Pharmacodynamics, Pharmacokinetics, Contraindications, and Adverse Effects. Diazepam is a medicine of benzodiazepine family which acts like an anxiolytic. The molecular formula is C16H13Cl N2O. The IUPAC name of this drug is 7-chloro-1,3-dihydro-1-methyl-5-phenyl-2H14-benzodiazepine 2-one. The common brand names of diazepam are Valium, Diostat, and Diostat Acudile. Synthesis of diazepam. The starting material is 4-chloroaniline. 4-chloroaniline reacts with benzyl chloride. In the presence of zinc chloride, undergoes Speidel-Crafts acylation. A hydrogen from this position of 4-chloroaniline combines with Cl of benzyl chloride and eliminates in the form of HCl, which results in the formation of this compound. This is being treated with chloroacetyl chloride. A hydrogen from NH2 and Cl from chloroacetyl chloride gets combined and eliminated in the form of HCl, which results in the attachment of C double bond O CH2Cl to the nitrogen. Here is the product formed. This on treatment with ammonia undergoes ring cyclization, which results in the formation of nordiazepam. It has been treated with methyl chloride or dimethyl formamide, results in the formation of diazepam. Properties of diazepam. It is an off-white to yellow crystalline powder which doesn't possess any odor, which is slightly bitter in taste. The melting point is around 125 degrees Celsius. It is very slightly soluble in water, sparingly soluble in propylene glycol, and it is completely soluble in benzene. And this compound, when it is being heated, it decomposes and emits a very toxic fumes of hydrogen chloride and NOx. Routes of administration of diazepam. It can be administered orally in the form of tablets through mouth, or it can be injected through intravenous injection, or in the form of drops through nose, which we call it as intranasal, or in the form of a suppository through rectum. Uses of diazepam. Firstly, anxiety disorders. It is effective in the short-term management of anxiety disorders by providing relief from symptoms like excessive worry and restlessness. Seizures. It is used as an anticonvulsant to control and prevent certain types of seizures which are being associated with epilepsy. Muscle spasm or twitches. Diazepam acts as a muscle relaxant which helps to alleviate muscle spasm and stiffness. Reduce the symptoms of alcohol withdrawal. It is sometimes used in the treatment of alcohol withdrawal symptoms due to its calming effect on the central nervous system. Preparation and dosage. The dosage of diazepam orally for adults will be in the range of 2 to 10 milligrams. Pharmacodynamics of diazepam. Benzodiazepine receptor agonist. It acts as a positive allostatic modulator at the gamma aminobutyric acid receptor. Sedative hypnotic effect. Diazepam possesses sedative properties which leads to the calming effect and making it effective for treating anxiety and prompting sleep. Anxiolytic action. It possesses an anxiolytic effect which has been primarily attributed to the modulation of ZABA receptors in the limbic system, by reducing the excessive neuronal activity which is associated with anxiety. Muscle relaxant properties. It acts centrally on the spinal cord to produce muscle relaxation by enhancing the inhibitory effects of GABA. Anticonvulsant activity. Diazepam is being used to manage seizures due to its ability to increase the inhibitory actions of gamma-aminobutyric acid, thereby reducing neuronal excitability. Pharmacokinetics of diazepam. Diazepam is well absorbed after oral administration and it reaches the peak plasma concentration within 1 to 2 hours. It's been distributed widely over the body into tissues and it crosses the blood-brain barrier, and it is also lipophilic. The metabolism occurs at liver by the cytochrome 450 and it's been eliminated through kidneys in the form of urine. Diazepam contraindications. Allergic reaction. Individuals with known allergy or hypersensitivity to diazepam or any other benzodiazepine should avoid its use. Myasthenia gravis. Diazepam is contraindicated in individuals with myasthenia gravis as it can worsen muscle weakness. Sleep apnea. Due to its respiratory depressant effects, diazepam has been contraindicated in individuals with sleep apnea. Severe hepatic impairment. Individuals with severe hepatic impairment should avoid diazepam as impaired metabolism can lead to drug accumulation and toxicity. Ataxia. Diazepam is generally contraindicated in individuals with a history of ataxia as it can exacerbate the condition. It may cause drowsiness and impaired coordination which can potentially worsen the symptoms of ataxia. Pregnancy. The diazepam is contraindicated in the first trimester due to potential risk to the developing fetus. So next, coming to the adverse effects. The adverse effects of diazepam are the allergic reactions such as skin rash, itching, hives, swelling of the face, lips, tongue or throat. It also causes CNS depression, slow or shallow breathing, feeling faint, dizziness, confusion, trouble staying awake. It leads to the thought of suicide or self-harm, worsening mood, feeling of depression. So what all we have learned from this chapter? In a nutshell, we have understood the mechanistic pathway for the synthesis of diazepam, its therapeutic importance, pharmacodynamics, pharmacokinetics, and also realized the contraindications and adverse effects of the drug. Thank you.